HL7 FHIR, indeed health level 7, fast healthcare interoperability resources, which is a mouthful, as topic for today's presentation. And briefly about me, I'm a full professor of medical informatics at Amsterdam University Medical Center at the University of Amsterdam. I'm a principal educator on FHIR data and a principal investigator on reusable health data, and involved in various European and Dutch projects in which FHIR data plays some role. This includes HEMA-FHIR and Helios, for which this meeting series is being organized. ARDERA, the European Rare Disease Research Alliance, in which we're developing a FHIR virtual platform for sharing, exchanging, and bringing together rare disease data. Leapfrog, which is a Dutch project on drug-drug interactions, especially pertaining to drug-induced acute kidney injury. Paladin, in which we work on a so-called patient interaxiom for neuromuscular diseases, and LearnFHIR, in which we develop open educational resources on FHIR data. So in the past, this is a slide from my previous presentation and relating also to the presentation that César Bernabé gave earlier in, I think, session 4 of this series. When we talk models and generally information models, there's quite a few in the domain of medicine. And even specifically for the domain of rare diseases, we see that common data models are being developed. So we have in the previous lecture talked about OMOP CDM, the clinical document model relating to the Odyssey initiative. There's quite a few more OpenAIR or OpenEHR, if you will, on clinical data storage in a patient record. Pheno packets focusing on information modeling for bioinformation. CDISC, which is a set of standards pertaining to clinical trials. And previously in EJPRD and now continued in ARDERA, we're working with the CARE semantic model, a semantic information model focusing on capturing disease, well, specifically for the rare disease cases, but not necessarily restricted to them. And today we will talk about HL7 FHIR, which is a standard for clinical data exchange. So today's presentation, I will cover, well, before I get to FHIR, I will well, first address HL7 as an organization, then some of the other standards being provided by HL7, just to make you aware that HL7 is much more actually than just FHIR, but then in the end we will focus on the FHIR standard. So the name sometimes puzzles people. Why 7? Well, health level 7 refers to the OSI level 7, which is the layers for, well, exchange of information. And if we look at those, we see the lower layers, 1, 2, 3, that is about establishing communication. So the physical, the data link, and the network layer, which is all the wiring or wireless that we rather not care about, that we, I think, nowadays take as granted. And on top of that, we get transport layers, we get the so-called sessions, especially for consistent, continuous exchange of information, the presentation layer, and the application layer. So health level 7 refers to the application layer, described here as the high-level protocols, such as for resource sharing or remote file access, such as HTTP. And actually, well, HL7 FHIR is a lot about HTTP, but the hypertext transmission protocol, basically the protocol that we use in our web browser, but I'll get to that later. So health level 7 as an organization is good to realize this is a standards development organization. So it's one of these organizations that focuses on, or is geared towards developing standards, well, in the domain of healthcare. And it has been established in 1987, so it's getting close to 40 years by now. And it's a member organization where there's a whole set of corporate members, which include healthcare providers, government stakeholders, payers, pharma companies, vendors, and consultancy firms. But apart from having these corporate members, HL7 also has a large set of affiliate countries. And each of these affiliates that you see here in the dark green, they have established their own national HL7 affiliate. So there's an HL7 Canada, there's an HL7 Argentina, there's an HL7 Brazil, there's an HL7 the Netherlands, Sweden, etc. HL7 Australia. And what we see here is that it's really adopted globally. We see Americas, Asia, Europe, Australia, and we see some different kind of affiliates in Africa, which is organized through HELINA, which is the African Medical Informatics Association, if you will. So through HELINA, also the African continent is involved in the use and further development of HL7. Because, all the development taking place, the standards development taking place in HL7 is through the members that basically contribute volunteer time to do that work. So it's not like a massive standards office with their own personnel, which don't do anything else than developing standards. Rather, these standards are driven by people who use these standards in practice, experience maybe problems with standards in practice. So it is really a practice and community-driven organization. And when I say standards, I want to mention a few without going into real detail, but merely because you may sometimes come across these names, and then just know that these are also part of HL7 or the HL7 set of standards. There's the Ardent syntax, which focuses on guidelines. There's the clinical document architecture, which is basically a content specification for electronic health data exchange. It specifies a whole set of chapters for exchanging EHR data. The clinical quality language, which I'll skip for now, and then the messaging standards, which were previously called version 2, version 3, and the current version of this standard, HL7 FHIR. So for these messaging standards, if we look at version 2, which is from, one of the earliest since HL7 was established in 1987, which was based on the electronic data interchange as it happened in the, late 20th century. We see a fragment of a message here. We see it starts with MSH, which stands for message subject header, basically describing what kind of message is being described, or what kind of message this is. And then if we read on, we see things like epic ADT, lab ADT, some date, and then we see it is an ADT caret A01 message. And if you would go through the documentation, you can find that ADT is admission, discharge, transfer, and A01 that is actually patient registration. So this is a message in which a patient, and that is, as you see in the third line, John Appleseed, is being registered. And John is maybe born 1971, 0101, and male, I guess that's what the M is. So between all the vertical bars, we see the various fields. We see an address and so on, and we see a contact person, Barbara Appleseed, the wife of John. So this was the first way in which messaging was established, which worked. But on the other hand, it was experienced that there was still much room for interpretation. And that meant that if multiple parties would implement HL7 version 2 messages, it could be that two parties could communicate with each other, but a third party would have followed the same guidance, but implemented it slightly different and could not communicate with the others. And further, it was hard to maintain consistency among the various messages. Because you can imagine that, well, this is patient registration. Well, we can have a patient discharge message. You can imagine that if registration changes, that maybe the discharge message would also need some change. And that was very hard because this was all basically handwritten specification of the contents. So consistency and scalability was an issue. And therefore, in the late 20th century, around 1990, 1995, I think, HL7 version 3 was developed, which adopted, I should say, the then, well, leading format, XML. And here we see what, in this case, an observation would look like. A part of an XML message, an observation event, which describes the assigning authority being GHH lab filler orders. And if we read on, we see the display name for whatever is being conveyed. The observation is a glucose post 12 hours. And we see some further information. And then at the bottom, we see the value, which is a PQ, meaning a point quantity, and that's 182 milligrams per deciliter. So now we see that where we previously had to fully interpret what does each of the fields mean. I see an M, that's probably male, and the documentation would then clarify whether I was right or wrong. Here, there's much more information already because, well, I read about code systems, status codes. I see that it's about an effective time. I see that 182 is actually the value of the observation. So this model-based approach made it, well, easier to understand, to interpret messages, and made it easier to make the messages consistent. But on the other hand, for these messages to be consistent, it meant that there was a very large model being created. There was a very small so-called reference information model, the HL7 RIM, but on top of that were all kind of models in a layered approach, which ultimately led to such a large number of models that, again, maintaining consistency and actually also understandability of all these models was a challenge. And that's where around 2014, it was thought that it was time to kind of start from scratch and see if HL7 could come up with a new approach to really make messaging easy. And that was labeled as HL7 FHIR, Fast Healthcare Interoperability Resources, where FAST focuses on the easy to implement, as opposed to version 3, which was quite challenging and complex to implement. Well, healthcare, of course, for the domain. Interoperability, because it is about connecting systems. And it is developed around resources, the so-called building blocks for exchange of information. And actually, I must admit, well, I don't have to admit it, the name FHIR, it is kind of a backronym. So they came up with, they wanted something else than for, should be kind of for, came up with FHIR and came up what FHIR could stand for. And apart from it being a unique name, so whenever you search for FHIR as FHIR, you will find anything about the HL7 standard. So it is a well-chosen name, and actually I think the meaning of the acronym is apt. So then the question is, what is HL7 FHIR? Well, it is a messaging approach based on the current web technology. And well, like the previous versions, HL7 version 2, current was using pipe symbols. Version 3, then current was using XML and SOAP, if I'm not mistaken. And now the current standard is web technology, the so-called REST APIs. And REST stands for representational state, and API stands for the application programming interface. So basically, this is the language, if you will, that is being talked among computer programs between clients and servers. And this representational state, well, I will not go in all the details there, but it largely means that, well, whatever you need in a request to as a client to a server, that whatever you need is represented in your request. So it's not an ongoing communication where I say, give me information about patient X. And when I have the answer, I say, okay, can you tell me some more? But that you would always, again, refer to patient X saying, okay, and now for patient X, I would like to have observation information, for example. So each request contains the complete state. The requests are common web requests, and I already mentioned HTTP, and I will show that later on. So basically, the requests are the same requests that we are using when we use our browser. But when we use a browser, the responses are HTML, and we will see them as web pages because they are rendered and presented graphically. In the HL7 FHIR language, the responses are a structured form for data. And basically 3 forms are being supported: JSON, XML, and RDF. And JSON stands for JavaScript Object Notation. XML, which we also saw in version 3, is the Extensible Markup Language. And RDF is Resource Description Framework. I will, in this presentation, use the JavaScript Object Notation, JSON, because that is, well, I think, currently the most commonly used representation, most commonly used syntax for representing data. So what does this look in practice? If I would send a request, a GET request, to a server, I can ask, in this example, for information about a patient, and we see that it's /patient, and knowing the patient ID, I can ask for /patient/596634. So basically asking the happy.fhir.org server, get me the core information about this patient. This is a typical HTTP GET request, and the response will be JSON, which you see below, which is all tuples, like a resource type. Okay, I ask for a patient 596634. What do I get? Well, the resource type is a patient. That's great. I ask for a patient, I get a patient. The ID is the ID of the patient I was asking for. Then I get some metadata about version ID, when it was last updated. I get some text stating that this patient is Ziki Zhu. And I get further data. I get an information, an identifier, where we see the value is LZU316. Name information, family name being Zhu, given name being Ziki. Telecom information, a phone number, an email address, a gender, a date of birth, and an address. So all this patient information is represented in a structured fashion in this case, a piece of JSON. And this is basically all that happens all the time whenever you communicate using HL7 FHIR. And I've, well, present here a few examples. So I could also, and all of this, of course, depending on permissions, but well, this is a demo server, so I can do a lot of things on that. I can ask for all patients, and then it will, and likely limited to 100 at a time. I can ask for basically /patient. So I don't present an identifier, and this is all part of this RESTful paradigm. I just present the type of resource that I'm interested in, the patient resource, and I get basic information about all, and like I say, likely in batches of 100, all patients. If I know a patient ID, I can retrieve that information. I can actually also search for patients, but I have not included an example, I realize now. I can also, again, if rights permit, insert information. So I can write patient data into a record by using not a get, but using a post request. And then, and sorry for being a bit technical here maybe, whenever you post to, well, in this case, this patient URL, you will also provide a message body. And this message body is a little piece of JSON, which then describes the information about the patient, similarly as to what was being returned when I retrieve information about the patient. And of course, there's much more than just the basic patient information like contact name, etc. So in the record, I could also say I'm interested in observations being done on this patient. And then I can query not a patient resource, but an observation resource. But I can query those observations for which the subject is, well, the identifier for this patient. So in this way, it is all basically a simple game of HTTP requests and JSON answers. And there are loads and loads of common tools, so not only from the HL7 FHIR community, but also in general, to process the requests and to process the responses. But what HL7 is about is, of course, about the set of resources being supported. So we saw that there's a patient resource, we saw that there is an observation resource, and the question then, of course, is, okay, what resources are there? And if we look at the hl7.org/FHIR, we see various types of resources. And well, I've highlighted patient and observation as those were the two that I already showed. But well, especially looking here now at level 3 and level 4, we see that we have administrative resources like patient, practitioner, care team, organizations, location, etc. And we have the record keeping resources, allergies, problems, procedures, observations, medication requests, medication dispense, medication administration, etc. So the importance and really the core of FHIR is these resources and the specifications of these resources. So if you go to this page, all of these resources are, well, clickable, so you can get more information. And for example, looking at the patient resource, you will see a specification of what is in a patient resource, or maybe better phrased, what can be in a patient resource. Because if we look here, we see the tree-like structure describing the attributes of a patient. And for each of the attributes, it describes the cardinality. So is it at least 0, at least 1 maybe? Can it be at most 1, or can it be? Can we have multiple of these attributes? we see the type, whether something is like an identifier, a Boolean, a code, a date, a piece of text maybe. And we see descriptions of so-called terminology binding. Yeah, I see my mouse is showing. Maybe I can pick the pointer. So if we look here, we see, for example, for gender, that it is coded and that it is bound to the administrative gender terminology, which is a terminology which is part of HL7. And here it actually says, if you code gender, and gender is single valued, so if it is represented, it can be at most 1. It must be represented using administrative gender. And then we have as possible values male, female, other, and unknown. And another binding that we see, which is slightly different, because here we see it's a code, is something which is a codable concept, like marital status, that binds to the marital status codes. And here we don't see the example or a delimitative list of possible codes. So here we see that marital status is represented using some marital status terminology. And in this way, and we see, well, what do we see more? Multiple birth. So if a patient is one of well, twins or triplets or multiplets, maybe there's a photo of a patient, etc., etc. Well, the contact information we saw the telephone number, we saw address, and we even saw email, which I don't see here. So this is a specification of the attributes of a patient resource. And in the same way, we can look at the information of the observation resource. And it gets the same information. And this is the full set of attributes. And of course, you can't read that. So I'll zoom in a little and I can read it, but that's not necessarily what it's about. But what we see here, well, the specification of the attributes of an observation, which again has an identifier. We see that it can be triggered by something. Here we see what I was using in my query, so that you can search for an observation by subject. And here we see the description, who and or what the observation is about. So this observation was about patient 5, 6, etc. So we have the subject as attribute of the observation. We have something about effectivity, which can be an effective date time, or an effective period, or an effective timing, or an effective instant. And well, if you observe something, it generally has a value. So we see that it can have 0 or 1 value, which can be a quantity, a codable concept, a value string, a Boolean, an integer, range, ratio, time, date, time, period, or even an attachment. So you may ask, okay, how helpful is it that a value can be basically anything? Well, I'll get to that because it's important to realize the role of resources. So resources are deliberately defined in a permissive way. So when you say it has a value, you don't want to be too restrictive, because if you say upfront, oh, this value should be an integer, you couldn't have observations with maybe including decimals or having yes, no as an outcome. So the resources are permissive. The minimal cardinality is often 0, meaning that very little attributes are really mandatory in a resource. Often multiple options for representing information are provided. So you can use text or codes or maybe dates, just like we saw with value. And that means that if in a concrete situation you want to exchange information, or maybe also for a concrete resource, you may want to be more restrictive. And that's where profiling comes into place. So in HL7 FHIR, you can specify profiles which provide constraints on resources. And then you can say, for example, okay, this attribute is mandatory. Maybe in the resource, it says, okay, this is an optional attribute. But if, for example, in the Netherlands, we agree that we must always use our citizen service number, then we can say, okay, that is type of identifier, which is mandatory in a Dutch information exchange. We can exclude attributes. Maybe in the Netherlands, we say, oh, we don't want to exchange race information. And then we say, okay, race is not part of the Dutch patient profile. And you can add new optional or mandatory attributes. So as an example, I took a specific observation, the blood pressure observation, for which we can create a profile. Because it's important to realize the resource is very generic. It's an observation resource, and it could be any type of resource, any type of observation. So if I want to be more specific about a blood pressure, I need to create a profile for that. And this profile constrains observation. That's the first thing shown here. The blood pressure is a profile for an observation. And it specifies that the code system, here it says fixed value, actually it says LOINC. And the code is a fixed value, which is 85354-9, which is the LOINC code for blood pressure. And then we see that the blood pressure has a body site, a method, and a set of components. A systolic blood pressure, a diastolic blood pressure, etc., etc. So what is done here is creating a profile for the observation resource. So to almost come to a conclusion on the technology part, HL7 FHIR provides a RESTful API with web requests, HTTP requests, and JSON or XML or RDF responses. The FHIR standard specifies permissive resources with very little restrictions, which is basically the common ground for, well, establishing the exchange of information. And in specific implementations, you can specify profiles which are use case specific, like this Dutch blood pressure profile that I showed. And it is important that all the capabilities of services are also made available and specified in a machine readable way. And I'd like to show that because we saw, well, everything we get is JSON. If we ask for a patient, it's JSON. If we ask for an observation or specifically a blood pressure, we get JSON. And even we can ask a server, what can you do for us? And that is with the /metadata URL. And then we see here, for example, that this server, responds and says, okay, I have the patient type resource, which adheres to the structure definition of patient from HL7 FHIR. But for this patient resource, I support a whole set of profiles. And this comes from this demo server, the HPFHIR server. So we see a whole bunch of things, which is, my patient profile. So this is all playing around by people using this server. But we see it uses a large lot of, or it supports a large number of profiles. And it also shows, and that goes on here on the right actually, the interactions that you can like search for patients, that it is possible in this server to update patient information, to read patient information, to delete patient information, create patient information, and even a few more. So if you, well, or if you have a piece of software that needs to find out what the server can do, this is the answer of the server. It says, okay, you are allowed to delete, to create, to read patient information, and patient information can or may or will adhere to these profiles. And well, here we see the line numbers of this snippet. This is line 33,000 something. So such a capability statement is actually quite well extensive, and that's, I think, the great thing. This is not something that you would normally read, but where machines can, well, negotiate and say, okay, what profiles does the server support? What profiles does the client know? And if you have a joint profile, you can use that profile as a common ground for communication. So all of that can be done in an automated fashion, and that reduces the implementation burden and reduces the possibility of inconsistencies. So there's one more thing that I like to bring up here, and that is that it is not just for patient information and things like observations, but FHIR also deals with terminology. So increasingly, FHIR servers are also being used as terminology servers. And I'd like to show a few examples of that and then wrap up. So I can go to any FHIR endpoint, and instead of asking, give me all patients that you have or give me all observations, I can say, get me all code systems that you know or that you have included in your system. And with the /code system profile resource, with the /code system resource or the /code system request, I will get as an answer the code systems being supported. And actually the SNOMED server, which I need to check if that's on my next slide. Oh, this is just a duplicate slide, sorry. So the SNOMED server, this, well, you can browse it, you can look at it, have the human interaction. It does provide a proprietary SNOMED interaction, but it also supports the FHIR API for dealing with the contents. And then I can, for example, query a code system for a subset of concepts. So this is an example where I say I want to use the IHTSDO or the SNOMED terminology server. And I look for SNOMED CT, and I look for all hereditary hemoglobinopathies. And this is the concept identifier for hereditary hemoglobinopathy. And creating a request like this, and of course, you would have to learn and understand and work with the syntax, but then you can, again, have your HTTP or HTTPS request and get as a response not patients, not observations, but concepts where it basically says, okay, in SNOMED, there is delta beta thalassemia trait, thalassemia in mother, sickle cell trait in mother, sickle cell anemia in mother, hemoglobin E, beta 0 thalassemia, etc., etc. So we can use the same mechanism as we use for patient data to query terminology services. So where are we today with HL7 FHIR? Well, there is a very broad uptake by industry. I'd say the majority of EHR vendors have FHIR implemented one way or another, or are increasingly implementing it. but also large companies like Google, Apple, Microsoft, Amazon have shown interest and have worked or started working with HL7 FHIR. So that's the, let's say, commercial aspect, but also from policy and legislation aspect in part of US and also, well, most likely like the European health data space, legislations and regulations, they refer to HL7 FHIR. There is a very large and active community, and I showed what countries have their national affiliates, and I here show how large players are involved. There's a very broad range of tooling, so there's much available online to, well, lay your hands on and experience and experiment with. And, well, the number of puns on things being on fire is endless. There's many initiatives, hospitals on fire, smart on fire, SNOMED on fire, you name it. There's a lot of collaboration going on. OMOP on fire, the collaborations, as my last presentation referring to. So there is really a lot of work going on. So to conclude, HL7 FHIR provides a web-based service architecture and a RESTful API. The standard specifies resources plus a bunch of other things. It enables use case specific profiles to make it fit for purpose, and it supports patient data and terminologies. Excuse me. I here mention a bunch of sources, and the slides will come on Zenodo, and then you can check all these links. So the FHIR specification itself, the open source server where you can like play around with all the requests. There's this is an open source API which you could like implement yourself. There are some demo servers like one with HPFHIR and MELD, which does provide a FHIR endpoint. Then we have FHIR terminology servers like for SNOMED, and one from New Zealand, which provides a large number of value sets. And, well, if you want to play with REST APIs, I've been looking for something that doesn't require any registration, etc. Hopscotch is actually, I think, a quite nice environment for playing around, putting in such a request and seeing what response is provided by the servers. So with that, I'd like to conclude. Thank you very much for your attention. I see that there are some remarks in the chat. I don't know if these are questions, but happy to take any questions.
Thanks a lot, Ronald. It was a great presentation and lecture. So yeah, as Ronald mentioned, we can start the Q&A session if anyone has any questions. Yeah, I see Peros's hand.
Hi, thank you, Ronald. Very nice as always. So maybe this question I asked it in previous lectures as well. So let's say that we have a registry that is not, aligned with FHIR or whatever. It could be a REDCap one or a custom-made relational database and so on. So, and we want to become aligned, if this is the right expression, with FHIR. So what are the recommended steps? Do we need to go on a totally different server and transfer our data in that FHIR supporting a server, let's say? Or do we build like a model on top of that database that we have that brings the data from the original database? What are the main steps, the starting point,
Yeah.
let's say?
Yeah, well, a very good question. And I must admit, I haven't done this in practice, so I cannot well reflect on whether this is easy or hard. And I think it also depends on, let's say, the quality or the extent to which your source data is already structured. So what we saw is that, well, this blood pressure example, which is always a great example for many cases, you must know, of course, what data in your local database, like in your RedCap or in your database, are the blood pressures. So if you have represented that in, well, let's say in Greek, then for me, it would be very hard to get it out. If you have called it maybe blood pressure or BP, I might be able to discover that those are blood pressures. And if you have already identified them by saying, well, this is a blood pressure and this has either a SNOMED code such and such for the observation or LOINC code, as I showed, for the observation, then it gets already a bit easier. So that's the first thing that will well influence the extent to which it's hard or simpler. But suppose that you have things, well, let's say fairly well organized. Yeah, then it is basically a matter of some transformations to say, okay, I've given a different name maybe to, well, gender or date of birth, but I know what field in my database represents date of birth. And then it's basically the transformation internally to say, well, however it's implemented internally, it can be transformed so that outward facing, if you will, it is shown as such a FHIR resource. And from what I have seen is that yeah, the tooling and also common supporting languages like Java, for example, well, are increasingly making that easier to do. So, well, I've been programming like since, well, maybe 30, well, maybe even 40 years. When I started, you had to do everything yourself, and now you have mapping functionality. So you can say, okay, I know my source, I know my target, and I can define a map which helps me to do this conversion. So, but still, you would have to do these conversions to say, okay, I have my local patient data, I transform it into a FHIR resource, which I can then exchange. And conversely, if I allow a write, insert, and someone provides me with a patient resource, I know how I have to store the various elements of that resource into my local database. But if your data is well structured already, even if it is not well structured as FHIR, yeah, it is quite well doable.
And so I will let Maria ask her question and I will follow up.
Hi, Ronald. Thanks for the talk. I was wondering about the profiles, because you said you showed the example with the list of different profiles that they're using, and most of them were on HAPI server, if I spotted it correctly. Do you have to put it up there? And is there an easy way to compare existing profiles with what you would like to share so you do not replicate someone else's work again?
Thank you so much for that question. I think that is because, well, there's a lot of things I really like about FHIR. There's well, some things I struggle with, and maybe it's not even that I'm struggling with FHIR as is, but I'm struggling with the way people are using FHIR. And that's exactly this area. Everyone can profile anything, which means that we can, and of course, like I say, this is a demo server. So the fact that this looks a bit messy, that's perfectly fine, because that is for learning. But you want to prevent that. Well, if I want to share data with you, that we have to agree on one profile. If I want to share data with Petros, that I have to agree on another profile. And if I want to share data with yet someone else with DLAM, that I would have to agree on yet another profile. So all of this is ultimately a matter of proper governance. And I feel, but I can only hope that I'm wrong, that this governance is not sufficiently in place as far, meaning that there is no simple repository where you can say, oh, you're looking for specific observations. Oh, there's 1,000 observation profiles for blood pressures, for temperatures, for body weights. And the Netherlands has done something, and Italy has done something, and Norway or whoever. So this is something that I think really needs, well, like I say, governance, and that we really need to establish and collaborate on, because otherwise we end up saying, oh, we all use the same standard, but we all use it in a different way, and therefore we still cannot communicate adequately with each other. And then, so if you have or select a profile, if you implement adherence to that profile in your server or in your server, you would include that in your capability statement and say, okay, we can deal with this profile. Is that an answer to your question, or maybe in part? Then feel free to follow up.
It was in part. I was also wondering whether there's a way to compare profiles, just so I know whether some are the same under different name, basically.
Yeah, that is very well possible. So we started that. We had a student working on that on, well, basically servers, because even and I didn't explain that in my presentation, but even for a FHIR server, like I say, you can specify whether you support read, whether you support update, whether you support delete. And a FHIR server can specify whether it supports patient observation, medication request. So the simplest FHIR server is a FHIR server that says, I am a FHIR server, but I don't support any profile, any resource, and I don't. Then it is still a FHIR server, though it's of course a totally useless FHIR server. And we started doing such a comparison and seeing that indeed there are differences where, well, like a patient resource is probably supported in 100% of the FHIR servers, but, well, there are corners, and maybe like terminology, maybe something that is, and code systems, something that is not supported by each FHIR server. And ultimately, we want to take that further, indeed, to profiles, so that you can say, oh, you support that profile, I support this profile for patient. Let's say that we take patient or observation as an example, and then compare and say, okay, are we talking about the same thing? Do we do the same thing? Is the structure the same? Is it different? Yeah, I know mechanisms how to do that. I don't know of any tools that do that for you, well, right away up front.
Okay, yeah. Thank you.
That covers it. Great question, great topic. Thanks a lot. Yeah.
I also saw Stella's hand, I think, if I'm not mistaken. Stella, would you like to ask a question?
Hi. Actually, it was a little bit part of what Maria asked, and a little bit of Petra. Just wanted to clarify if your system does not have a REST API, how can you implement FHIR, or what are the steps needed to ensure compliance and interoperability, if I make sense?
Yeah, so and maybe I at the same time relate that to the question I see from Cesar being put in the chat, because I think that relates. He says, I would like to know more about the relationship between FHIR and FAIR. I guess there needs to be more fuel for FHIR-enabled data resources to burn into FAIR. Yes, one more pun. So yeah, I think it's well, and I don't want to repeat myself. So and please follow up on my answer now. So I think one thing is, like I said, well, it's working on standardizing of the data as you have it, aligning it to the FHIR resources and relevant FHIR profiles. I think as FHIR for a FHIR server to become fair, you would also need to add information like, well, what's the provenance of this data? Where does this data come from? I mean, if I have a FHIR endpoint with general practitioner data, it will be totally different from having a FHIR endpoint with critical care data. So if I if I want to draw any inferences or learn from whatever is in such a FHIR server, I would need to know that kind of information as well. Well, things like access and reuse conditions. I think all of that is not natively specified in FHIR. And actually, one of my PhD students, and I'll post it in the chat, did a piece of research on that. Sorry, I'll have to. Yeah, he researched the extent to which HL7 FHIR services are fair. So that was assessing the use of HL7 FHIR for implementing the FAIR guiding principles. And as I said, I'll put that in the chat if the system allows me to. So they are. Yeah, I don't think I'm. No, I can. I'll do that in a different way. Yeah, virtual. Oh no, there it is. 3 times even. Good. So FAIR and FHIR, I would say so you can use FHIR without being fair, and you can be fair without using FHIR. But well, yeah, using them both, I think would be a great step forward. One thing to add is that, well, like last presentation, OMOP CDM really being a standard for secondary use, so for analysis on a population, and maybe even federated analysis on a population. I would say that the core of HL7 FHIR is exchanging information about individual patients. So this is really geared towards primary use. That doesn't mean that there are no initiatives to use FHIR also for secondary purposes, but that's a different story. Do you want to follow up on that, or does this answer your question sufficiently?
No, it's okay. Okay. Thank you.
Thanks.
Okay, do we have any other questions for Ronald before we wrap up the session? Okay. we are already 5 past, so
Yeah.
I think that was a great session with a lot of useful discussions, I think. So thanks a lot, Ronald, for your time again. It was again a pleasure to have you here. And thanks everyone for joining.
Thanks for having me. Yeah.
So our next session will be on the 27th of March on ethical, legal, and social issues. And the lecture will be announced soon on our social media channels. And as Ronald mentioned in his presentation, the lecture slides for this lecture will be available on Zenodo account for FHIR as well as the website, along with the video recording. So thanks again, everyone, for joining. And I hope to see you soon. See you later. Bye-bye.
Thanks all.
Much.
And have a nice day.
Bye. Bye.
Bye.